guys got these definitions written down, but I hadn't really talked about it much. So we're really talking about different branches of statistics and the main things that we can do. So descriptive and inferential. Descriptive is what it says. You're just describing what you found. So I took a survey of people in this classroom, and 8 out of 10 said they want to take this class for college credit. Okay, I just told you what I found. Inferential is when you are taking that and trying to make some inference about the population as a whole. So it might be, all right, 8 out of 10 in my classroom said they want to take this for college credit. So I'm going to assume 80% of high school students want to take college level classes. Okay, is that a good assumption? Probably not. We need to talk a lot more about what's good and what's a bad assumption. But I tried to take the information I had and extend it to make some guess about a bigger group. Do you guys understand the difference between those? Okay. So we talked yesterday about the difference between a population and a sample. What's a population? The entire group, all high school students. What's a sample? The small group, the people in this classroom. Okay. Then we have parameters and statistics. Both of those things are numbers. So 80%, okay, that's a number. It's either a parameter or a statistic. What I remember is the P's go together. So a parameter describes the population. That would be saying 80% of all high school students want to take this for college credit. Okay, the 80% is describing the entire population, so it's a parameter. If the number is describing your sample, it is called a statistic. So if I said 80% of students in this class, you are my sample, so then that 80% is a statistic. Right? So the P's go together, the S's go together. Let's look at some examples. So I think we have our definition slide, and then I printed my actual slides with the examples. So example 1. First, let's just decide if we are descriptive or inferential. The average age of 500 surveyed students in your institution is 23 years. Did I describe what happened, or did I make a guess about it? Descriptive. I'm just telling you what I found. Based on a sample of 10,000 Americans, it is fair to say that 70% of all Americans are overweight. Inferential, because I did not survey all Americans, but I'm making a guess about all of them. 80% of students in your statistics class dislike true-false questions. I mean, I guess it's higher than 80%. I hate true-false questions. Based on a sample of 20,000 college students, we may conclude that 80% of all college students dislike true-false questions. Parameters or statistics. Suppose the percentage of all students on your campus who have a job is 84.9%. All right, so we have to first decide, are we talking about a sample or a population? Yeah, we're just talking about all students on our campus. So that's the population. So that means this 84.9% is a parameter. 80% Suppose a sample of 250 students is obtained, and from this sample, we find that 86.4% have a job. We are talking about a sample, so in this case, the 86.4% would be a statistic. NBC News conducted a poll in 2013 and asked, do you favor or oppose raising the minimum wage to $10.10? They surveyed 1,009 adults and found 706 were in favor of an increase in the minimum wage. CBS reported that 70% of Americans were in favor of the increase, with 3% error and a 95% level of confidence. We'll talk about error and level of confidence later on. But just right now, reading the scenario, I want to know 3 things. I want to know what's the population, what's the sample, and what's an individual. So what do you think? What would be our population?
Americans.
More specifically, American what? Yes. I don't really care what my 6-year-old has to say on the topic, just the adults. What would be the sample?
1,000.
And individual.
Singular person.
Okay. Are there questions about populations versus samples, descriptive, inferential, parameter statistics? The second piece that we have to talk about in this section is different kinds of variables. So we're going to go back to our definitions for a minute. Variables are the characteristics of individuals in the population. It's the thing that I'm concerned about. So whether I'm surveying you to see how many of you want to take college level classes, or maybe I'm surveying you to see how many of you have brown hair. It's whatever I'm concerned with. That's my variable. We have 2 different types of variables. So I can call it qualitative or quantitative. Qualitative, sometimes that's called categorical, but I will usually just say qualitative, deals with the quality, an attribute, hair color, eye color, something non-numerical. Quantitative deals with quantities. It's a number. I do want to warn you, you can't just assume everything you see with a number is quantitative, because sometimes we use numbers but they don't have a numerical meaning. For instance, like your bank account, right? It has a number, you have an account number, but is that number really numerically significant? No, it's just a way of distinguishing from one person to the next. Like your social security number. We all have a number, but I can't add 2 social security numbers together and get something meaningful. Even though it's a number, it's just there to keep one separate from another. Does that make sense? So quantitative is numbers, but it has to be numerically significant. Let's practice those. So I want to classify each of these things as qualitative or quantitative. So this is on your examples handout again. Nationality, qualitative or quantitative? Number of children. Household income in the previous year. Quantitative. It does have a meaning. You know, you can rank households in order using those numbers. So that would be quantitative. Level of education. So that's like saying, do you have an associate's degree, bachelor's, master's, doctorate? Daily intake of whole grains measured in grams per day. Right. We're going to be measuring it using grams, so that would be a quantitative. Alright. In just a little bit, I am going to be giving you guys some to practice on your own. So far, is this clear with everybody? Then we can also talk about if these things are discrete or continuous. So qualitative is really just by itself. Okay, if it deals with an attribute, that's really all you can do with it. So we have variables. Okay, it can be qualitative, it can be quantitative. If it's quantitative, then we can break it into discrete and continuous. So discrete is meaning it just has a countable number of possible values. Okay, so something discrete. How many pairs of shoes do you own? We can count the number of shoes. Continuous has an infinite number of values. So think like continuous would be something involving decimals, right? I know I can't have 2.3 pairs of shoes, but if I were talking about weight, okay, the weight of an object, you can have decimals, and we could round to 1 or 2 or 3 or 4 decimal points, so that makes it continuous. We cannot just sit and list every possible value. So let's try some examples with that. So this is from our previous example, all the ones we said that were quantitative. We can decide if they are discrete or continuous. So number of children, would that be discrete or continuous? Discrete. Household income the previous year. It is discrete. It has decimals, which is a little misleading, but when we're talking about money, how many decimal places do we use? 2. So could we list every possible income? Yeah, it's annoying, but we can list every number with 2 decimal places. It's when those decimals could keep continuing that it would become continuous. Daily intake of whole grains measured in grams per day. That would be continuous because you could have a partial gram there and it's not set to only go to 1 or 2 decimal places. All right. we just have a couple examples that we're going to look at together still, and then we're going to do some individually. I apologize because I know this didn't print very well. It's kind of hard to read. But this is a table. It has a country, lists their government type, life expectancy, and population. So looking at this, we're just going to practice applying some of the words that we've heard. What are the individuals in this?
Countries.
Individuals will be each country. Okay. The variables. What things am I collecting information on?
Life expectancy, population,
And one more.
government type.
Yep. So for each country, we did the government type, the life expectancy, population. All right, for those variables, qualitative or quantitative. So government type, what is that? Life expectancy. It's measured in an age, so it's quantity. And population, of the ones that are quantitative, we could decide, are they discrete or continuous? Sure. So discrete means we can list all the possible values. Continuous is when we have an infinite number of values, so things that are decimals without just a set number of decimal places. So if we look at our life expectancy, it was in years. Did we just round everything to the whole year though? No, we listed decimals here. So would that be discrete or continuous? All right. And the population. Yeah, it's misleading here if you look, it's in decimals, but it's just measured in millions. Okay, so 22.5 million. But if you're counting people, we don't have a partial person, right? So that is a discrete value. So, final thing for these variables. They sometimes talk about level of measurement. This is one thing that is not always cut and dry. There's a little bit of gray area, a little bit up for interpretation when we are trying to decide these. Do you want me to let you write and then talk? This is the last thing we're going over today. These deal with the level of measurement. And basically everything starts at the top, and then you might be able to get more specific from there. So we start, no matter what I give you, it's at least nominal. So nominal level just means we can break it into categories. Okay, one isn't better than the other. I can't put them in any kind of meaningful order. Something like where you were born. Okay, I can't say it's better if you were born in Hannibal versus Quincy versus Moberly. There's not one better than the other. We can't do like gender, ethnicity, marital status, even things like eye color, hair color. Okay, you can break up people into categories, but then you can't rank those categories in any way. So it's strictly nominal level data. Ordinal is when we take it a step up. So we can still have categories, but we can rank them. So things like medals. Okay, we all know the gold medal is the best, and then the silver, and then the bronze. If you were looking at like your language ability, okay, are you a beginning Spanish speaker, intermediate, are you fluent? Like we can put those in a meaningful order, an order that doesn't just make sense to me, but we would all agree makes sense. Even something like offices, you know, it goes president, vice president, so forth. You can put those in some kind of order. Okay, then it goes up to intervals. So you notice it's building. It still can be categorized. It still can be ranked. But the next condition, it is evenly spaced. Okay, so what that means is if I'm looking at, I put things in order, is it the same distance to get from this step to this step? If I were going back to like metals, does it really make sense to measure the distance between a gold and silver and a silver and bronze? No. But if we're looking at temperature, can we put temperatures in order? Yes. Is it the same distance between 96 and 97 as it is between 97 and 98? Yes. So I can put them in order and they're evenly spaced out. The final level is ratio. So it has all the same. Categorized, ranked, evenly spaced, but the key has a natural zero. Why isn't temperature a ratio level? Yeah, we can have negatives. There isn't a stopping point. If I'm looking at height, though, can you have a negative height? No, there is a definite lowest that we start at. Weights, there is a lowest. Age, those kinds of things. If there is a clear zero, and you can only go up from there, then that makes it ratio.
What about test scores?
Test scores, you can't, we're going to assume no negative scores, so not like a test where you get penalized for a wrong answer. So just, that would, that's one that you could probably make an argument either way. So some of these, there's a little bit of gray area. You know, most of the time, there are tests where you get, like, if you get a right answer, you get 3 points. If you get it wrong, you get a -1 to deter guessing. So there are some standardized tests like that, so it technically doesn't have to have a natural zero. You could have a negative. We just don't usually see those. So that would be one that you could probably argue your point either way. In general, nominal and ordinal, that's usually your qualitative data. And interval and ratio is typically your quantitative data. All right. Let's look at this example. Okay, a study was conducted to assess school eating patterns in high schools in the U.S. Blah, 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 blah. So I just want to know the level of measurement. Okay. The number of snack and soft drink vending machines in the school. So everything starts at nominal. We can categorize it. Okay, ordinal. So our rule is, if we can put it in order, it's ordinal. Can we put the number in order? Yes. Okay, let's check, is it interval? Are they evenly spaced? Is it the same distance between 1 and 2 vending machines as it is between 2 and 3? Yes. Let's check. Can it be ratio? Is there a natural zero? Can you have 0 vending machines?
Yeah.
Can you have a negative number of vending machines? No. So this one would be ratio data. Right. B, whether or not school has a closed campus policy during lunch. So we know it has to be nominal. Ordinal, it's a yes or no. Can I put that in order? No, not an order we would agree on. Maybe you think yes is better, maybe I think no is better. We're not going to agree. So this is just strictly nominal. Okay, class rank, freshman, sophomore, junior, senior. So can we break them into categories? Yes. Can I put those in order? Yes. Are those evenly spaced? Maybe, but not really in a mathematical sense, are they? No. Let's look at it this way. I told you the first two are really qualitative and the second two are really quantitative. Freshman, sophomore, junior, senior. Is that qualitative or quantitative? Qualitative. So we know it's really probably going to stop here. So this is ordinal data. The number of days per week a student eats lunch. All right, so that one, is that qualitative or quantitative? Quantitative. So we know it can be categorized. We can put it in order. Does it have what am I trying to say? Evenly spaced?
Yes.
Yes. Does it have a natural zero?
Yes.
Yes. So this would be ratio data. All right. If you pull out your Chromebooks, I posted a practice for you. It's not a grade, but I just want to see how you guys do. So it's got 3 different sections. The first one, you're just deciding if something is qualitative or quantitative. Second one, you're just deciding discrete or continuous. And then the final, you're putting them nominal, ordinal, so forth. So try that.